Hi, I'm Brad and welcome to my course. Before we get started, I just wanted to say that if at any point you get stuck on something or need more of an explanation, hit the help button and write down what you're stuck on. I'll get back to you as soon as possible. I hope you enjoy this course and that it gives you the foundation to confidently build with XState and React. You can find the source code for this project in the lesson resources section below. If something goes wrong, such as a bad dependency version, you can download the code and check out whichever step you're up to. Each commit message is matched to the name of the step. The first thing we need to do is get the 4 environment tools we'll need for development. They are Node, npm, yarn, and VS Code. We can install npm, node, and VS Code from these 2 websites. The addresses will be in the resources section. This page will get us npm and node with this installer, and this will get us the VS Code installer. We can then use npm to install yarn. So in the terminal, we write npm install -g for global yarn. That looks like it's installed properly. And just to confirm, we can write yarn-b, which will return the version we have installed. The tools we'll be using during this course are XState for state management. XState is based on finite state machines, and I think they are a significantly better fit for developing user interfaces than other solutions available. We'll also be using React for rendering the user interface. Although we won't be implementing any of React's state management functionality, its approach to rendering is great and has a huge community behind it. TypeScript will be used for its ability to find bugs and increase development speed when used with VS Code's IntelliSense. We'll also be using Storybook for almost all of the development, as I think it makes for a far easier development environment rather than trying to build in-app. Lodash will be used for some utility functions, and for styling, we'll be using style components. The reason for this is styled components allow us to use the same component composition as React instead of having to introduce an additional concept to our code base, such as CSS classes. I think the less concepts we have, the simpler things are. So this is what we'll be making. The first screen is the home screen, which has this start game button. And when the player clicks it, we'll transition to level 1. In this level, the player can use the keyboard arrow keys to move around our grid. And this level is just to introduce them to the moving mechanics. We've also got these 3 hearts up here that represent the player's health. And when the player moves to this square, we assume that's them moving through the door, and we'll transition to level 2. So this level has this monster on it, and if the player moves onto the same square as the monster, they'll lose one of their hearts. If they lose all 3, we'll transition to the game over screen with this restart button, which takes them back to level 1. So if the player is able to avoid the monster and we move to the door, we'll transition to level 3 that has this treasure chest on it, which is our win condition. So when the player moves onto the treasure chest, we'll transition to the game complete screen, which has this go home button, which takes us back to the home screen. The first thing we're going to do is get the boilerplate for our project. So in the terminal, type in npx create React app. We're going to call this project Pixel Thief and we're going to be using TypeScript. Okay, that looks like it's gotten everything successfully. So if we open our project in VS Code, open the terminal and type in yarn start, we should see our boilerplate React app. Perfect. Now we're going to remove any of the unrequired boilerplate. So if you go into the source directory of a project, open up the index file, we can remove the index.css, and in the app file, we can remove all of this. Just export const app. And for now, we're just going to put app placeholder to make sure it still works. And then we can remove all of these files. And because we're using export const, we have to change this import. And hopefully it's still working. Perfect, there's our app placeholder. Throughout this course, I'm not going to be using export default. I'm just going to be using export const. This is because it makes it easier to keep exported and imported names consistent. Here we are going to add the dependencies needed for this project. So in the terminal, type yarn add XState at XState/React, styled components and the types for styled components, Lodash and the types for Lodash. Okay, we'll also need prettier. So let's add that as a dev dependency, yarn add -d prettier. Now with prettier, we'll need a prettier ignore file. So in our root directory, just add a file, call it .prettier ignore. And you can just copy the git ignore for this one. The last thing I want to do is add a prettier settings file. So again, in the root, add a .prettier rc.json. And in this file, I'm just going to set my tab width to 4. This is just my personal preference, so if you prefer a different width, feel free to skip this step. One more thing we'll add that will make things easier is the VS Code extension for styled components. So if we go to our extensions menu and just type in styled components, we'll get this one up here and just hit install. This will add syntax highlighting and IntelliSense for our components made with styled components. We're going to add Storybook to our project. If you're unfamiliar with Storybook, it's a development tool that allows you to make components in an isolated environment rather than making them in-app. This makes development significantly easier. So in our terminal, we're going to type npx sb init. We need to install the following packages, sb, say yes. So that's all you need to install it. Storybook is pretty clever at figuring out what environment you're in and what it needs to install based on that. Okay, so that looks like it's installed correctly. Storybook will add this stories folder to your source directory. We can just delete that. We won't be needing it. And what I'm going to do now is just make a mock component just to confirm Storybook is working correctly. So in our source directory, make a folder, and we'll call it components. And this is where all our components will live. And we'll make a folder in that directory, and let's call it my component. Now this folder will have two files in it, an index file where the code for our component will live, and an index.stories.tsx file. And this file will render our story of our component. So we'll make our component, it'll be very simple, just export const my component. And it will just be a div with my component placeholder as the text. And we'll need to import React. Okay, so now we go to our stories file, and we'll need to export default as meta, and we'll need I think it's going to auto import that. So what I'm doing is importing the type from Storybook, and this is an object which describes our story. Types 6.0. So in this object, we add a title property, and this title will show up in the Storybook menu. So I'm just going to put my component in here. Now we need to define what we're actually going to render in Storybook. So export const index, and this is just going to be my component. To import React, and this is supposed to be my component, not components. And import that. Okay, So now we need to start Storybook. So in the terminal, we can just write yarn Storybook, and this will start the Storybook server. This. So if we go to that address, okay, so this is Storybook. On the left is a menu of all of our stories. And we can see we have my component, and my component placeholder is rendering correctly. So one thing I want to do is change some settings. So you can see here there's this padding around the left of our component, and that is being rendered by Storybook. What I'm going to do is turn this off because it can get confusing about where this padding is coming from. Is it a margin on our component, or is it something else? So I think it's best just to remove it, so you know that anything rendered in this square is just our code. So the way we can do that is we go to this .storybook directory, and in the preview, got this parameters. We'll add another property called layout, and we'll just set that to full screen. And you can see the padding is now gone. Perfect. In this video, we're going to get the assets we need for this project. So on the lesson page, just click this download assets link. And if we unzip this, there'll be two folders. A fonts folder with the font we'll need, and an images folder with all the images. So all we need to do is copy both of these folders into our source directory. And that's it. We're going to add a theme to our project. In the context of styled components, a theme is an object that contains values that we would want to use to style our components, such as font sizes or colors. This will help keep styles consistent and makes development quicker. So in our source directory, I'm going to make a new folder and call it styles. And in this folder, I'm going to make a file called theme.ts. It's going to be export const theme. This will be of type default theme from styled components. This will be an object, and the first thing I'm going to do is define some colors. So I'll add a color property. I'm going to add black. This will be HSLA 0, 0%, 0%, 1. I'm going to add a focus color, which will be a blue. 207, 90%, 54%, and 1. And I'm going to add a white color, which is LA 0, 100%, 100%, and 1. I'm also going to add a font size array with two different sizes, 16 pixels for our body text and 40 for our headings. I'm going to add a font family property, and this will have our custom font, which is VCR OSD mono, and the fallback will just be mono space. And the last thing I'm going to do is define a space property, so space pixels 4. Now what this last property is, it's for defining the size of our implicit grid. So whenever I define some padding or margins on a component, instead of using a number such as 16 pixels, I'll use a multiple of this space size. when all our dimensions are a multiple of this number, it makes our design look more consistent and organized. A better name for this property would be grid square. However, our game will be using a different type of grid for positioning items in the play area. So to avoid confusion, I'm just going to call this property space. Okay, so that is our theme file. We need to make a theme types file. So in the styles directory, add a style.d.ts. Just move this next to it. And I need to import styled components. I'm going to declare module styled components, and then export interface default theme. And I'm just going to copy all of our values from our theme and just rewrite all the values as types. So this will be string again, string again. This will be an array of strings. This will be string, and this will be number. Okay, so that is our theme file and our theme types file. I'm also going to make a function using this space property, which will come in handy in future lessons. So under styles, make a new file, and just call it space.ts. And it's just going to be export const space, and I'll have one argument, the amount of space squares you want to use, which will be number. And this is just going to return the amount times theme dot space in pixels. We'll put pixels at the end of that. Okay, so now we need to use start components theme provider and wrap our app with this component. So at the root component here, we're gonna import the theme provider from start components, wrapping our app. And this takes a theme prop, and we're just going to pass in our theme. So what this will do is whenever we make a styled component, it will have access to our theme values through its props. And we also need to do this for our storybook environment as well. So if we go to storybook in preview, we need to export const decorators. So this will be wrapping all the stories we make. There's one argument story, and then bring in our theme provider from start components. We need to pass it our theme. Auto import's not going to work for this one. Import theme from source styles theme, and then just put our story in here. And we're also going to need to import React. Okay, so we'll just confirm this is working by going to our mock component, my component, and let's go to Storybook. So we can see that my component has no background and is just rendering black text. So let's change that using our theme. So I'm going to make a styled component of this div. So const, just use div equals style.div. We'll have to import styled components. Now I'm going to make the background black, the black value from our theme file. So the way I do that, open some brackets, and this will be a function with the props argument, and the theme should be on our props. So props.theme.color.black. And let's make the text white. So color props.theme.color.white. And then replace this with our styled component. Go back to our story. Yeah, perfect. So we can see that the theme values are being passed through to our styled component. Now we're going to add a global styles component, and this is going to act as our CSS reset. So in our styles directory, make a new file, call it global styles with a capital because this is a component, and export const global styles. We'll call styled components create global styles function. Just import that. Open up our string. And the first thing I'm going to do is at font face and define our font. So the font family will be VCR OSD mono, and the source will be URL, and we'll open up a variable. And I'm just going to import our font file. So import VCR OSD mono from fonts/VCR OSD mono.ttf, and just use that in here. Now we're getting this TypeScript error because TypeScript doesn't understand this .ttf file. So what we can do is we'll have to create a types directory, and in that add a file global.d.ts and just declare module any file ending in .ttf, and that got rid of our error. Okay, so that is our font imported. The next thing, I'm just going to do some baseline styling for all elements. This is just some pretty common box sizing, border box, margin padding 0, color inherit, and then just a bunch of inherits for size, style, weight, and family. So next I'm going to target the HTML and body elements. I'm going to set them to width 100%, min height 100 vertical height units to make sure they fill the full screen vertically. I'm going to set display to flex, and color, we're going to use our theme object for this. So we theme, import theme.color.white, and for the background, the theme.color.black. Now we'll target our root element that renders our React app. We'll set that to width 100%, min height 100 vertical height units, position relative, display flex. This one's going to have flex direction. Flex direction, we're going to set that to column. And we're going to align items flex start. I'm going to set the font size using our theme again, theme.font size. Font size, set it to the first size, which was 14 pixels, our body copy size. and the font family, theme.font family. And we'll set line height 1.4. Just some other basic reset styling. So for UL, just set the list style to none to remove the bullet points. For our image, we're going to set display block. This removes some pixels below the default display in line. For any links, we're going to turn off text decoration, so remove the underlines from links. For buttons, we're going to set the background to transparent. Turn off any borders and set the cursor to pointer. For any disabled elements, we're just going to set pointer events to none. And the last thing, for any element focused, we're going to set an outline of 1 pixel solid and use our theme focus color, theme.color.focus. So that is all of our global styles. Now we need to import this component into the root. So just in our theme provider, we'll have to open up a fragment because we're going to be using 2 elements here, and just add global styles here. Just import that, and we also need to do the same for Storybook. So in our Storybook directory in preview, open up a fragment and global styles. We need to import that. Import from source styles, global styles. So because in our global styles we have set our background to be black and our color to be white, we should see that in Storybook. Yeah, perfect. So now we know that our global styles is working correctly in Storybook. And if we go to our app, again, a black background and white text. In this video, we're going to create a button component. So this is a mock-up of our game, and this is the component we'll be making. It's used on the home screen to start the game. It's also used on the game over screen to restart the game, and on the game complete screen to go back to the home screen. So in our components directory, we'll make a new folder and call it button. And inside here we'll make an index file and a stories file. Now our button is going to be pretty simple, so we can just make it a styled component. So export const button equals styled dot button. And it'll have padding, and we'll use our space function, top and bottom padding of 3 spaces and side padding of 6 spaces. We're also going to add a border, and it'll be 2 pixels solid, and we're going to use the white from our theme file. So props.theme.color.white. We're also going to make any text in the button uppercase. Text transform Okay. And because we're doing that, I'm going to increase the letter spacing by a little. So whenever you're using all caps for a word, it tends to look a bit compacted. So it's recommended that you add a little bit more spacing between each letter. And that's our button component. So now we need to write a story for it. So we'll export default object as meta. And then for the title, I'm just going to write button and export const index. And that'll be our button. And we have to we'll put some text in the button. So we'll just write start game. And we'll also need to import React. And so now we should have a story for our button. It will appear here. So here's our button. Perfect. Now what I'm going to do is I'm going to put this button in a category. So in the title, I'm going to add small components / What that will do is group any components. It will put it under this small components category. It just makes things a bit more organized and easier to find. And now that we know that our storybook is working, we can get rid of this my component. Perfect. Now we're going to add a heading component. The heading is also used on the menu screen. So up here, this is our heading rendering Pixel Thief. On the game over screen, it's rendering game over. And on the game complete screen, it's rendering quest complete. So like before, in our components directory, we'll add a new folder and we'll call it heading. And it'll have an index file and a stories file. And this component is also pretty simple, so it can just be a style component. Export const heading equals styled.h1. And the only thing we need to do for this one is set the font size. And we'll be getting that from our theme dot font size, and it'll be the second value in the array, the bigger value. So now we create a story for our heading. So export default title. Before I do that, fix the spelling here, and as meta. And the heading, we're also going to put it under this small components category / heading. Title, not heading. Okay, and now export const index and heading. And we'll just add some text. Import component, add some text, and we'll just put game over. So now if we go back to our storybook, we should see, yep, there's heading, game over. Perfect. We're going to make the menu screen component. So if we look at the mockups for our menu screens, the component we're making is the parent component of these screens. It'll be the full width and height of the viewport, and it'll center any children it has and add some spacing in between them. So we go to our components directory, make a new folder, call it menu screen. I'll have two files, index and index.stories. will be export const menu screen. Again, this will just be a style component, style.section, import style components. So we'll set the width to 100%, and we're going to say flex grow 1. Because the parent of this component is a flex component, which we set in global styles. So the root will be the parent of the menu screen. And because this is display flex and flex direction column, setting flex grow 1 means that this component will take up all available vertical space. This menu screen will be the only child of the root component, which means it'll take up 100% of the vertical space. And considering this is a min height of 100 vertical height units, it'll be the full height of the screen. So that's width and height. Now I'm going to set display flex for the children, flex direction column, and we're going to justify content center. So that will vertically center any children and align items center. That will horizontally center any children. And now for any child, except the first child, I am going to add a margin top, use our space function, and it's going to be 8 space units. Need to auto import that. Okay. So what this is doing, if we look at our mockup, so for any child that's not the first one, so for this image and this button, we're adding a margin above them just to give some space. So that's our component done. Now we just have to make our story. So export default as meta. And title, small component / menu screen, and export const index, just the menu screen. And I'm just going to add 2 children just to confirm that they are being centered and there is space in between them. So let's first import React and import our component. So just a div, child 1 placeholder, and child 2 placeholder. So if we go to Storybook, we should see our menu screen is added to the menu with our 2 children in the center of the screen and a space in between them. Now we are going to make an image component. This component will be used on our menu screens to render this image, as well as in our level screens to render any images inside the grid, as well as these heart icons. So in our components directory, make a new folder and we'll call it image. And we'll add 2 files, index.tsx and our stories file. Now for this image will have 3 different sizes. So for our menu screen, this will be the large image size. And then on our level screens, anything in the grid will be a medium image size and the heart icons will be a small image size. So the first thing I'm going to do in our component is create an enum to describe this. So export enum image size type. And we're going to have small, which is just small. medium, and large. Now the prop types for our component will take one of these sizes, props type, and we'll call the prop size. And we'll make it optional, and I'm going to set medium as the default. So we export const image, and again, this can just be a styled component. So we import style.image, and we'll add the props type to it. Now I'm going to need a function that maps one of these values to actual pixel sizes. So up here, I'm just going to make a function, const get dimension, and we'll take size, image size type, and we'll just write some if statements. So if size equals image size type dot large, I'm just going to return 20 space units. Just need to import this. If our size is small, size type dot small, and return 10 space units. And for our default case, which would be the medium size, it's going to be the size of a grid square. So I'm going to pull that out as a constant because we're going to be using it in other areas, not just in the image component. So I'm going to create a new directory, just call it constants, and just add an index in here. Export const grid square size, and this will be 64. And that'll be the size for our default case, which is the medium. So return grid square size, and that'll be in pixels. We just need to import that. Okay, so back to our component. Width, the props dot, we'll call our function get dimension, and we'll pass in props dot size. And it'll be exactly the same for the height. And I'm going to use object fit contain. So this will make sure that whatever image file we load into this component, it won't overflow the container and it'll still maintain its aspect ratio. I'm getting an error for this. It's not a sign. Because we need to make this optional as well. So hopefully that makes our error go away. Yep, perfect. Okay, so that's our image component done. So now we just need to render a story for it. So export default as meta. Just import that. And title, again, this will be in our small components category / image. Now I'm going to render 3 images for this story, 1 for each size. So I'm just going to make a layout component to wrap all these images. Import styled components. So display flex because I want them all to be in a row. And I'm just going to target each child except the first one. And I'm just going to add some space to the left. Call our space function, and I'll just use 4 space units. We just need to auto import that. Okay, so now export const index. First use our layout. I'll need to import React. And we'll render our image component. For some reason that's not auto importing there. And I also need an image to render. So I'm just going to use our thief GIF for this story. So import thief GIF from our images directory. Images/thief.gif. So source equals thief GIF. Alt will be thief. And size, use image, size type, need to import that. Oops, there it is, image type, and we'll start with large. And we can just copy that, and for the medium size, we don't have to pass in a size because it's our default, and we'll just change this to small for the last one. Okay, so if we go to our storybook, we have our image added, and there are 3 image sizes. Perfect. In this video, we're going to create a level background image component. This component is going to be used on all of our playing screens to render the background of the playing area, which would be each of the dungeon rooms. So in our components directory, create a new folder, call this level background image. Like before, it has an index file and an index.stories file. Now this component can just be a style component. So export const level background image for style.image and import style components. Now we're going to put this, we're going to render this component in the middle of the screen. And it will be underneath other components. So we'll make it position absolute, top 50%, left 50%, transform, translate, minus 50%, minus 50%. Okay. Now we need to write a story for it. So export default as meta. And the title, again, it will be in the small components category and level background image. Export const index. Level background image. We need to import React and import the image. And we'll also need to import the picture of a level background. So I'm just going to use the level 1 background. Level 1 background PNG from, go to our images, level 1 background.png. Source, level background, and alt equals a dungeon room. That should be it. So we go to our story. There is our level background. Now we are going to create a health component. This component will render the hearts you see above the level playing area. They represent how much health the player has left. So in the components directory, make a new folder, call it health. And as before, make an index file and index.stories file. Now, the first thing I'm going to do is make a layout component, and this will be the parent for the hearts. Just make it a div. And we'll use display flex to render the children in a row. And then for each child, except the first one, we're going to add a margin left of 2 space units, which will add a bit of spacing between each heart. Okay, so now we'll make the health component, so export const health. There's our layout, and I'm just going to start with just 1 heart to begin with. So we'll use our image component. Need to import React, and then our image component isn't auto importing for some reason, so import image from image. Okay, and we need to import our heart picture. So import heart PNG from our images directory / heart.png. Source equals heart and alt equals heart. And we want to use the small size for this one. So image size type dot need to import that dot small. Okay, so that will render 1 heart. So let's make a story for that just to confirm it's working. So export default as meta. Title, again, this will be in the small components category, health. Now export const index, health, and import React, and import our component. So we should see a story with a heart. There it is. Okay, now I want to change our component so it takes a prop of the number of hearts we want to render, which would represent the amount of health the player has left. So interface props type, and we'll just say health, and it will be a number. And we'll add this to the function health. Now I'm going to create an array, and it's going to be the size of the health. So if we pass in, just for example, we passed in 3 for the health, this array would be of length 3. And we just need to fill it. It doesn't matter what we fill it with, so I'm just going to put in undefined, and then we're going to map over it. Now the value doesn't matter. It will just be undefined, so we don't really care about that. And we're just going to render an image, and I'm going to use the index as the key for this. Okay, so we go to our story and we're seeing an error here because it's expecting us to pass in a health prop. And this has to be the number of hearts we want to render. So I'm just going to put in 3. So in Storybook, we have our 3 hearts. Now we're going to make a grid component. You can see on this image, the grid is these squares, and they represent the playing area that the player can move around on. So the first thing I'm going to do is I'm going to create a story for this component because it'll make things easier to explain. So just make an index.stories file. It'll be export default as meta. Title, this will be small components / grid. And const index, I'm just going to use a placeholder for now. Grid placeholder. And import React, export const index. Just make sure that worked. Yep, there's our grid placeholder. Okay. So as you can see on our grid, it has 12 columns and 4 rows. So I'm going to set those values as constants to begin with. So we'll go to our constants file, export const number of grid rows equals 4, and export const number of grid columns equals 12. Now we need to make a coordinate system of our grid. So each grid square will have a coordinate associated with it. So this one would be 0, 0. The first number represents the x coordinate, so which column it's in, and the second number represents the y coordinate, so which row it's in. So this square would be 0, 0. This one would be 1, 0, and this one would be 2, 0, and so on. And the next row would be 0, 1. This one would be 1, 1, and this one would be 2, 1. And this will go all the way down to 11, 3. Now what I'm going to do is create a new directory in our source. Just call it util, short for utilities. I'm going to make a new file in that. I'm going to call it grid chords list ts. And this is going to be a function that's going to return an array of all of our grid coordinates. So we can use that to make our grid. So what this array is going to look like, it'll be an array, and inside that we'll have the coordinates of our grid in their own array. So we'd have 0, 0, 1, 0, 2, 0, 3, 0, and this would continue all the way up to 11, 3. So that is what we want. So I'm going to make a function that can make one row for us. So just go const row, and I'm going to use the array function, and I'm going to make this size 11 because that's the number of columns in our grid. and I'm just going to fill this with undefined. Doesn't matter what we fill it with at the moment. And then I'm going to map over all these values. Now I don't care what the value in each element is, because at the moment it's undefined, but I do care about its index. And so then what I'm going to return is a coordinate. And this is going to be the first, the x coordinate will be the index, and the y coordinate will just be 0, because this is the representing the first row. I'm just going to export that. And so in our story, I'm just going to console log out the value just to ensure it's working correctly. Console.log row. Now if we go to our storybook, just open up the console. I've got to call it. Okay. So here we have an array, and inside we have our grid coordinates for the first row. 10. I think we're missing one value. Records. We want 12 columns. So this goes from 0, 0 to 11, 0. So that would be all our top coordinates up here. But I want to change this function. I want to use it for all of our rows, not just the first one. So what I'm going to do here is I'm going to put in row level, which will be of type number. And then I'm going to use this row level for this second number, row level. And so that way I can create a row for each of our rows in the grid. So I'll put row, the first row. So this should be exactly the same as what we've got. Yep. Now if I change this, I want to make the coordinates for the second row. I can put in a 1 here. And yeah, it's creating the coordinates for the second row. So what I can do is I can go here, small const grid equals, and make an array, and I can just go row 0, row 1, row 2, and row 3. Now if I just change this to grid, and import that, we should have all the coordinates for our grid. Yep, so we have an array with 4 rows, and this is our first row, 0, 1, 1, 0, 2, 0. The next one is 0, 1, 1, 1. The next one, 0, 2, 1, 2, and the last one, 0, 3, 1, 3, 2, 3. Okay, so that's working. But we want to refer to our constant for the number of columns in our grid. We don't want to hard code this one, just in case in future if we want to make our grid bigger or smaller. So I'm just going to replace this 12 with the constant we declared earlier. So it'll be number of grid columns. And I also want to tidy this up because at the moment we're hard coding that we want 4 rows. But again, we want to refer to our constant that we defined for the number of rows. So instead of this, get rid of this, and I'll use the same pattern we did before. So I'll say array will be number of grid rows, and we'll just fill with undefined. It doesn't matter what we fill it with. And then we map over it. And again, we don't care about the value, but we do care about the index. And then I'm going to use our row function and then pass in the index, which would be what row level we're on. So this will be 4. So this I will go from 0 to 3. And we're passing that into our row function, which will mean it will make 4 rows, 0, 1, 2, and 3. And let's just make sure that's working. Yep, all the way up to 11, 1, 2, and 3. Okay. Now at the moment we've got an array of chords. I want to reduce that array by 1, so we just have an array of arrays. So we can use Lodash's flatten function for that. Just import that from Lodash. Awesome. So we just have one array of coordinates. And also I just want to change this function name to grid chords list to match the file name. Just change it here. And we don't need to export our row function because that's only used internally here. And we can get rid of all this. Okay, so this can be used now to create our grid. So let's make our grid component. So in our grid directory, make a new index file, index.tsx. And first thing I'm going to do is I'm going to make the parent component that's going to contain our grid. Const layout equals style.section, import style components. This is going to have a width. There'll be number of grid columns times grid square size and pixels. The height will be number of grid rows times grid square size, again in pixels. And we want to put it, that did not import correctly. Now we want to put this in the middle of the screen and it's going to be layered on top of our background image. So I'm going to use position absolute, top 50%, left 50%, and transform, translate, minus 50%, minus 50%. And we'll put a border around it as well. 1 pixel solid, and we'll use our theme, props.theme.color.white. Okay, so that's our layout component. Our next component will be a grid square. So const grid square. Again, this will be a style component. And each grid square is going to have to take in its coordinates to position it. So we'll make some props for this grid square. Interface props type. I'll have an X coordinate, which will be a number, and a Y coordinate will be a number. And we'll just add those props type to the style component. Now the grid square will have width of grid square size in pixels and a height of grid square size, again in pixels. It'll be positioned absolute, and top, we'll have to look at our props, and props.y times grid square size in pixels. Left, props.x times grid square size in pixels. And we'll put a border around each grid square as well. Props.theme.color, and we'll make them white as well. Okay, so last thing we need to do is create our final component that combines these two. So export const grid, and its type will make it React functional component because it will take children. Anything that's rendered on the grid will be a child of this component. So the player and the monster and the treasure will all be located in this grid. Children, and our layout component will be the parent component, and then we're going to use our grid chords list, and we're going to map over all the chords, get our x and y value, and then we'll make a grid square. We have to use a key, and we'll choose x and y to make sure they're all unique. And then our x chord will just be x, and y will just be y. And I think I need to import React, that's why we're getting these errors. And import grid chords list. And we're also going to have to render our children inside the layout. Okay, so if we go to our storybook, we should see our grid. Get rid of this. Oh, we have to actually update our story. We just got our placeholder at the moment. So I can get rid of this. And inside here, right, grid, and import that. And there's our grid, and we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 columns and 4 rows. In this video, we're going to make the home screen, which is this screen you can see here. It contains our heading component, our image component, and our button component. So make a new folder, we'll call it home screen. And add our index file and our stories file. So export const home screen, and we'll use the menu screen as the parent. Import that, and our heading component, we'll import that, and I'll put pixel thief. We also need our image component. And we're going to need our thief image, so import thief gif from our images directory, thief.gif, use that as the source for the image, alt thief, and the size we're going to use the large size. Didn't auto import, whoops. Large. And the last thing we need is the button. Auto import that. And the text will say start game. We also need to pass in a click handler for this button, so something actually happens when the player clicks this button. This function will just be passed through to this component. So we'll make some prop types. And we'll call this on start game button click. And it'll just be a function that doesn't return anything. We'll add these prop types to the component. So on start game, and pass that to the button on click. Okay, so now we just need to write our story. So export default object as meta. And title. We're going to put this in a different category than small components. We'll call this category menu screens. And this will be home screen. No space. Export const index. Home screen. Import React. Now we'll need to pass in a function for the on start game button click. So I'm just going to make a mock function that doesn't do anything. On start game button click equals mock function. And that should be it. So we have our new category menu screens, and here is our home screen. Now we're going to add the game over screen. This is very similar to the home screen that we just created. So we can just copy and paste this component. Just rename this to game over screen. Just open up the component and its story. And we need to change this home screen to game over. This on start button click, we're going to change to on restart button click. The heading will change to game over. The image will be the skull PNG from skull.png. The alt text will use skull, and the button text will say restart. Now in our story, we just changed this from home screen to game over screen, and this will be on restart button click. So if we go to our story, we should see a new menu screen turn up. Oh, it's already there. For some reason our home screen isn't on there. There it is, just need to refresh. So yeah, here is our game over screen. The last menu screen we need to make is the game complete screen. So like before, we can just copy the home screen component. Copy, paste this here, and we'll just rename this to game complete screen. Just open up the component and its story. So the name of this component would be game complete screen. The on click handler would be on go home button click. The button text will be go home. The image will change from the thief GIF to the treasure PNG. Treasure.png. Just add this here. Our heading text will change to quest complete. And I think that's it. We have to change this alt text to treasure chest. So now if we go to our story, this will change to game complete screen. And this onClick handler will be on go home button click. So go to our storybook, we should see, yep, there's our new screen. And that's the last of our menu screens done. We're now going to create our first machine. We're going to make the game machine. And in this lesson, we're going to write the logic that controls which screen the player sees. So whether they see the home screen, one of the level screens, the game over screen, or the game complete screen. So in our source directory, I'm going to make a new folder and call it machines. This is where all our finite state machines will live. I'll make a new folder in that and call it game machine. And each of our machines will have two files, of an index file, which will hold the machine, and a types file, which will be the types of the machine. So to create our machine, I'm going to export const game machine, capital. I'm going to use XState's create machine function. And this will take 3 types, but for now I'm just going to set them to any. And then you pass the create machine and object, which will contain the logic of our machine. So our machine will have an ID, and we'll call that game. And then it'll have a states property, and this will list the states our machine can be in. So we're going to have 4 states, 1 for each screen. So the home state, the playing state, game over, and game complete state. And we need to set what the initial state will be. We'll set that to home. Now I'm going to add events to this machine. So events can allow us to change state. So in the home state, I'm going to add this on property. Now I can write in an event type. And I'm going to add the start button clicked event type. And when that event occurs, we'll transition to the playing state. So while we're in the home state and this event start button clicked occurs, we'll transition to the playing state. If this event occurs while we're in the playing state, nothing will happen because we've only defined this event type inside the home state. So keep that in mind, that events are scoped to state. This is a powerful idea because it tells us what can happen in each state and where the user can go. So let's add an event to the playing state. So on, I'm going to add the player died event. And this will transition the machine to the game over state. I'm also going to add a second event to this state, which will be player got treasure. And this will change the machine to the game complete state. I'll add one event to the game over state, which will be the restart button clicked. And that'll take us to the playing state. And in the game complete state, there'll just be one event, home button clicked, which will take us to the home state. Okay, so what we've written here, this object is known as a machine config. And we can copy this machine config and go to XState's visualizer. So we type in xstate.js.org and click on visualizer. And then we can put our machine config in here, click update, and it'll give us a state chart, which is a diagram of our system, which is very handy for communicating or trying to understand what a machine does. Even for people who aren't programmers, can understand this diagram with a little training. So these squares represent our states. So we've got the home, playing, game over, and game complete states. And these oval looking shapes are the events. So we can see that in the home state, there's only one event that can occur, which is the start button clicked. And when that event occurs, we'll transition to the playing state. In this state, we can see two events can occur. If the player died event is triggered, we'll go to the game over. Or if the player got treasure event is triggered, we'll go to the game complete state. Okay, so if we go back to our machine, we now need to add types for this machine. So I'm just going to pull this over here. Okay, I'm going to make a type for each event. So export interface, start button click type. So each event is an object that it has to at least have one property, the type property. And this will be start button clicked. Need another one for the player died type, player died, player got treasure type, player got treasure. And we have two more, export interface, restart button clicked type, clicked, and the last one, home button clicked type, home button clicked. So these types have to line up with these types in here. Okay, so now I'm going to make export type game event type, which will be all the events that can happen in the game machine, which is just all of these. So I just copy these, paste them in here, like that. So that's our game event. And the last thing we need to do is export type our state type. So this has two values. It has a context. This machine has no context, so we just set it to null. We'll cover context in a following lesson. But we do have a value property on here, and this is the states the machine can be in. So the machine can be in the home state, or the playing state, or the game over state, or the game complete state. So now we just need to import these event types into here. So this first value is the machine's context type, which is null, because it doesn't have a context. The second one is the event type, so the game event type, and the last one is the state type, game state type. And that's it. In this video, we're going to make a game component, and we're going to connect this component to our game machine. So in our components directory, make a new folder, call it game. Like our other components, add an index file and an index.stories file. So our component will be called game. Now we can use the use machine hook from XState React, and we can pass it in our machine, game machine. Now this hook will return two values, state and send. State allows us to query what state the machine is in. And send is a function that allows us to send events to the machine. Now what we want to do is, depending on what state the machine is, we want to render one of 4 different components. So if state.matches home, we're just going to return some placeholder components. We'll say, we'll render a paragraph and just say state equals home. And we're going to have to import React as well. Now we're going to do a similar thing for all the other states. So if state.matches playing, return, say state equals playing. If state.matches game over, Mr. Capital, return state equals game over. And the last one, if state.matches game complete, return state equals game complete. Now, our machine only has 4 states, but if something goes wrong, none of these will return true. So just as a helper, we'll throw an error here stating that if none of these return true, throw error unknown game state and state.value. So we should never reach here, but just in case. I'm not sure if this is a function. Okay, so let's make a story. Export default as meta. No, that's the wrong meta. It's the one we want. Okay, and title, and we're just going to call this game, and it's not going to go in any of our categories. Export const index game. So here is our game component, and we can see state equals home, which is correct, because if we look at our game machine, we can see that our initial state we set is home. So I want to add some more, let's add some buttons here that allow us to change the state. This is just placeholder stuff, just to confirm that our machine is working. So we'll add we'll just use our button component for now. And this will be the start button. And on click. Okay, so now we'll use the send function that has been returned from the use machine hook. We'll send, and we can pass in an event. So we'll pass in the start button clicked event. So when we're in the home state and this button is clicked, this start button clicked event will go to the machine, which should change it from the home screen to the playing screen. So we'll go to our story. We can see that the state is home. Here's the start button when we click it. we change state to the playing state. Perfect. So let's add some more buttons for the rest of our states. So we'll add a new button here, and we'll add player died. Click, send, player died. If you can remember, while they're in the playing state, one of two events can occur. The player died or the player got treasure. So let's add two buttons to this one. One for player died and one for player got treasure. In the game over state, add a button. This will be the restart button, so on click, send, restart button clicked. And the last one, on the game complete state, home, go home, on click, will be the home button clicked. Okay, so with all these buttons, we should be able to go through all of our states. So we start in the home state. When we click the start button, we should change to the playing state, which we do. Now, if we click the player died state, we should go to the game over state. Perfect. And if we hit restart, we should go back to the playing state. And if the player got treasure event fires, we should go to the game complete state. Perfect. Now when we hit go home, we should go back to the home state. We're going to replace all this level placeholder with the level background image and the grid. So if we go to our components and we go to our game component, first thing I'm going to do is import our level images. So import level 1 background, B, PNG from images / level 1 background.png. Do the same for level 2 and level 3. 2, level 3. Okay, so in level 1, we can remove all this. Let's go. We use our level background image component. Source will be level 1 background PNG, and the alt will put dungeon room. Just need to import this. And I also want to add our grid component. Okay, we can do the same for level 2 and level 3. We just need to change these to level 2 and level 3. Okay, so if we go to our storybook, then we have our level background and our grid. So we know this is the level 1 image because it has no door on the left. Level 2 has a door on the left and the right. And level 3 has no door on the right. So our level background image has a grid in it, so we don't need to render, we don't need to show our grid. So I can get rid of all the white lines. So we go to our grid component, and I'm just going to remove these borders. So the grid will still be there, it's just that it's invisible. And as you can see, the background image perfectly lines up with our grid. Our game will have 3 levels. The first level where the player needs to move to this doorway to progress to the second level. In the second level, the player needs to move around this monster and again get to the doorway to progress. And in the third level, the player just needs to move onto the treasure chest in order to complete the game. In this lesson, we're going to add levels to our game machine. So if we go to our machines directory and the game machine directory and open up the index, we're going to modify this playing state. And what we're going to do is add substates to this state node. So the way we do this is we just add a states property to the state node, similar to here, and we just write the states we want. So we want level 1, level 2, and level 3. We also need to define an initial state, which will be level 1. So now the machine, when the machine transitions to the playing state, it won't just be the playing state, it'll either be playing.level1, playing.level2, or playing.level 3. So now I'm going to add some events to these states, just like we've done before. Level 1, we add the on property, and I'm going to add the player walked through door event, and that will go to level 2. And in level 2, I'll add the on player walk through door event, same as before, but this time we'll go to level 3. Now we've got these two events up here on the parent node, player died and player got treasure. We're not going to move these events into the substates. In our game, technically, the player can only die on level 2, and the player can only get the treasure on level 3. However, keeping these events on the parent node means that if the player dies in any of our substates, the transition will happen. So if a player dies in level 1, level 2, or level 3, the machine will transition from the playing state to the game over state. So if in future we decided to add more levels with monsters that can kill the player, we don't have to add this event to each of our levels. We can just keep it up here and define it once. So the last thing we need to do is add some types to this machine. So we added one event, was the player walked through door event. Player walked through door, and we just add that to our game events type. And now we need to add some states here. So we added the playing.level1, playing.level2, and the playing.level3. Now, technically, our machine does not have just a playing state. The machine will always be in the playing.level1, playing.level2, or playing.level3. But if I remove this, we do get a type error later on in the course, so I'm going to leave it here for now. But just keep in mind that our machine can never just be in the playing state. There was a typo here, it should be playing. The last thing I want to do is take our machine config and just put it in the visualizer again, just to show what the changes have done. So let's go back to the visualizer. So this was our original game machine with our 4 states and events. So I'm just going to replace the config with the new config. hit update, and you can see that the playing state has changed. Now it's got these substates inside of it, level 1, 2, and 3. It's got this curved arrow indicating that this is the initial state and the events for these substates. And you can see that these two events are on the outside of the state, so it doesn't matter which substate we're in. If one of these events is fired, the whole playing state will change to either game over or game complete. Now we're going to add some more placeholders to our game component, just to confirm that the addition of the levels to our game machine is working as expected. So if we go to our components directory in our game directory and open up our game, we're going to be changing this part here where we're querying the state for the playing state. So what I'm going to do is add a bunch of if statements for each level. So if state.matches playing.level1, and I'm going to do that for level 2 and level 3. Level 2 and level 3. Okay, and we're going to add some fragments for each one. And we're going to put in, just to confirm what level we're in, we're going to add this state.playing level 1 paragraph. Level 2 and level 3. Now, to go from level 1 to level 2, we had an event player walk through door. Player walked through door. So on click, send to the machine, player walk through door. And we had the exact same event for level 2. And remember that the player can die in any level, but in our game, there is only a monster on level 2. So we'll move this placeholder button for player died just to level 2. And in level 3 is when the player can get the treasure. Just get rid of that. Okay. So if we go to our storybook, let's refresh. Okay, we have made a mistake somewhere. We need to return all these. Okay. All right, looks like it's working now. Okay, so right now we would be in the home state. When we click the start button, we go to the playing.level1 state. And when the player walks through the door, we move to the playing.level2 state. And now one of two things can happen. The player walked through the door or the player died. So let's just do player walk through door. And that's worked correctly. So now we're in the playing.level3 state, and when the player got treasure, we're in the game complete state. Now if we do that again, go to level 2 and just confirm that the player died event is still working. Yep, we get the game over state, and we just restart. Perfect. At the moment, we've got a problem. If we want to say make changes to level 2, we would have to click through this start game button, then click on player walkthrough door in order to get to level 2 to see our changes. Now, if we then changed our code again, this would restart and would have to do the process all over again of clicking the start game button, clicked on walkthrough door just to get to level 2. This would make development very slow. What we're going to do in this lesson is add fast forward events. And what these will do is add new items to this menu screen to allow us to go directly to level 1 or level 2 or level 3 or any other screen without having to do all the button clicking. The way we do that is in our game directory, we're going to make a new file and call it fast forward events. And we're going to make fast forward events to get to each level and each menu screen. So our first menu screen is the home screen. We don't need any fast forward events for that because that's the default starting screen. So I'm going to write fast forward events for the next screen, which is level 1. So export const fast forward to level 1 events. And this will just be an array of the game events. Now, in order for the player to get to level 1, the only event we need is the start button clicked event. Okay, so the next one I'm going to write is fast forward to level 2 events. Now, that will use the fast forward level 1 events. And to get from level 1 to level 2, we only need one more event, which is the player walkthrough door event. Now, the next one I'm going to write is fast forward to level 3 events. And that will use the fast forward to level 2 events. And again, we only need one event, which is again, player walkthrough door. So that will allow us to fast forward to level 1, level 2, and level 3. We've got 2 other screens we might want to fast forward to. The game over and the game complete screens. So let's do the game over one first. So export const fast forward to game over events, game event type. And now in our game, our player can only die on level 2. So let's use the fast forward to level 2 events. And then we'll add an event, player died, which will then trigger the game over state. And the last one is exports const fast forward to game complete events. And this will use the fast forward to level 3 events. And only one event, which is player got treasure. Okay. So these arrays contain the events required to fast forward to anywhere in our game. Now, to use them, we have to modify our game component. And what I'm going to do is add a prop. Props type. And it'll be fast forward events, and it'll be optional, as we would only be using this in development. And I'll just take game event type arrays. and add this to our component fast forward events. Now I'm going to add a use effect hook. And it will have two dependencies, fast forward events and the send function. Now, if we have fast forward events, for each of them, we're going to send them to the machine. Game event type. To put these in brackets. Send event. Okay, so what should happen is if we pass an array of events to our game, this hook will trigger a send event to the machine for each event. Now you can batch events in XState, but at the time of writing, there was a bug which didn't work. So we're using this for each as a workaround. So the last thing we need to do is go to our game story and make some new stories to add level 1, level 2, level 3, game complete and game over to the menu. So the way we add more stories, export const level 1, game component and fast forward events, and we want the fast forward to level 1 events. Similar thing for level 2. Game, fast forward events, fast forward to level 2. Just need to import that. And for level 3, game component, fast forward to level 3 events. So there are our levels. Now for our game over, game, fast forward events, and game, fast forward to game over events. Just need to import that. And the last one, game complete. Fast forward game complete events. Okay, I think that's all we need to do. So if we go back to our browser, now we can see that in the game component, we have our index, but we also have this level 1, level 2, level 3, game over and game complete. So level 1 takes us straight to level 1, level 2, level 3, game over and game complete. So this makes it far easier to develop. In any stage of our game, we can go directly to it rather than having to constantly be clicking through menu screens and triggering events manually. We're going to replace all this level placeholder with the level background image and the grid. So if we go to our components and we go to our game component, first thing I'm going to do is import our level images. So import level 1 background, be PNG from images / level1 background.png. Do the same for level 2 and level 3. To level 3. Okay, so in level 1 we can remove all this. Let's go. We use our level background image component. Source will be level 1 background PNG, and the alt will put dungeon room. Just need to import this. And I also want to add our grid component. Yep. Okay. We can do the same for level 2 and level 3. We just need to change these to level 2 and level 3. Okay, so if we go to our storybook, then we have our level background and our grid. So we know this is the level 1 image because it has no door on the left. Level 2 has a door on the left and the right. And level 3 has no door on the right. So our level background image has a grid in it, so we don't need to render, we don't need to show our grid. So I can get rid of all the white lines. So we go to our grid component, and I'm just going to remove these borders. So the grid will still be there, it's just that it's invisible. And as you can see, the background image perfectly lines up with our grid. In this lesson, we are going to make a new machine, the player machine. And this machine will be responsible for the player. So in our machines directory, make a new folder, call it player machine. And like before, we add an index file and a types file. Now to create a machine, export const player machine. We'll call the create machine function from XState. And it takes 3 types, but we'll just set them to any for now. And the function takes an object, which is the machine's config, which will have an ID, which we'll set to player. It will have a states property, and our player will have 2 states, alive or dead. And the initial state will be alive. Now we can put this in XState's visualizer, xstate.js.org, go to the visualizer, and just copy our config, which is the object that we're passing into the function, update, and we can see it's a pretty simple state chart, 2 states, alive and dead, and this curved arrow indicating that the alive state is the initial state. So all that's left to do is add the types for this machine. So export type player state type. Doesn't have a context at the moment, so that will be null, and the value will be alive or dead. I also want to define an actor type. So export type player actor type equals actor ref, and import that from XState. And this takes a event type and a state type. We don't have any events yet, so I'll just set that to any. And the second argument will be the state type. So the term actor in this system is being used to describe machines that are spawned from a parent machine. Our game will have 3 machines: the game machine, the player machine, and the monster machine. The game machine will be the parent, and it will spawn the player and monster machines. These 2 spawned machines would be referred to as actors. The last thing we need to do is add this state type to our machine. So if we go across to here, it will be the 3rd argument. It will be player state type. And we're done. In this video, we're going to add the player machine to the game machine. So the way we do that is we go into our game machine, and we can see that we have our 4 states: home, playing, game over, and game complete. And playing also has its substates: level 1, level 2, and level 3. Now, we only want to bring in the player machine during the playing state. It's not required for the home, game over, or game complete state. So the way we can bring in a machine just for one state is by using the invoke property. So in the playing state node, we add invoke, which will be an object. And we want to give whatever we're invoking an ID. And I'll just give it player actor as the ID, but it can be whatever you want. And it also takes a source. And this will be the player machine that we created in a previous lesson. Just import that. Okay, so this will make the player machine. This means we can access the player machine during the playing state. So now if we go to our game component, the way we can access invoked machines in components is through the state.children. So if I go const, got state.children, and then we can inside here player actor. Now this variable name player actor has to match the ID that we gave it in the machine. Now I want to render a new React component for this actor. So in our components directory, make a new folder, call it player, and add an index file. And so make export const player. And we're going to return the thief image. So import thief gif from images thief.gif. We're going to use our image component. That source equals thief gif and alt will equal thief. Need to return this. And we have to also import React. Import React from React. Okay, the component will accept an actor. So we'll write interface props type actor, and it will be the player actor type that we defined earlier. And the way up, we have to add this to the component. So props type and actor will go in here. And the way we access the state and the send events function of an actor is similar to the way we do it for a machine. The only difference is that instead of using the use machine hook, we call a use actor hook, which is also from XState React, and we just pass in our actor. We're not actually going to use these two at the moment. I just wanted to set it up for future lessons. So if we go back to our game component, here we're accessing the player actor from the game machine. And now I want to add the player component to each of the levels. So I'll open up my grid component, and as a child, when you're accessing invoke services, you should always check that it's available before trying to use it. So player actor and component player takes the actor and pass in player actor. And we just do that for each level. And I think that's it. So if we go to Storybook, we can see our player is on each level, but not on the menu screens. We're going to add coordinates to our player machine. And so these coordinates will determine which grid square the player is in. So the first thing I'm going to do is go to our types directory and add a new file, index.ts. And I'm going to add 3 types. First one is going to be type X coord type, which will be number, and type Y coord type, again number, and then export type coords type, which will be an array of 2 numbers, the X coord and the Y coord. So the next thing I'm going to do is go into our constants, and I'm going to make a constant for the player's starting position. So if you look at our mockup, you can see that the player is starting in column 0, row 1. So export const player starting coords, which will be of the coords type that we just defined, and it'll be 0, 1. Okay, so now we can go to our player machine. And what I'm going to do is add context to this machine. Context is an object that allows us to store quantitative data such as numbers or strings, data that would not fit as a state. So the way we do that is I'm going to export interface player context type. Now we can add whatever properties we want in here. I'm going to add a coords property, and it'll be of the coords type. And because we have a context type, we need to update our state type. And that's it. So now we go to our player machine, and this first argument is the context of the machine. So we just add that and import it. Okay, so the way we add the context to the machine is just add a new property called context, which is an object. This will be coords, and the initial value will be the constant we define, so player starting coords. So now if we go to our player component, the way we can access the context is through state.context. So we const equals state.context, and this will have the coords in it. Now I need to be able to convert these coordinates to actual pixel values for the top and left position. So I'm going to make a new function in our util, and I'm just going to call it coords to position ts. So we export const coords to position, and this will take some coords of coords type, and this is going to change them to pixel values. So we're just going to map over the coords, so the X and the Y, This will be a coord. We're going to replace it with a string. It'll be the coord times grid square size, and we'll add pixels there. So now we can put in coords and we can get the left and top positions of our element in the DOM. So if we go back to our player, I can now get its position, const position equals coords to position, and pass in the coords. I'm going to add that didn't auto import. I'm going to make a new component, const layout component, style.div. There'll be position absolute. And import style components. And then we're going to wrap our image in this layout component. And now I'm going to add a style attribute, and we'll add the left, which will be position 0, which is our x coordinate, and top, which will be position 1, which is our translated y component. Now, the reason I'm using this style attribute and not passing left and top into this styled component is styled components will actually make a CSS class for every possible value in here, and I don't want to be creating that many classes. It's far more efficient to be using a style attribute for these coordinates. So now if we go to our storybook, we should see our character rendered in the proper square. Yep. So this is square 0, 1, which is the constant value that we set as the initial value for the coords in our player machine. This video is going to be step 1 to adding controls to our player machine to allow the user to move around the player by using the arrow keys. So what we're going to do is first get each arrow key press to be logged by the machine. So we'll start by going to our types file, and we're going to add a new type, the direction type, which will be an enum. So export enum direction type, and this can be left, right, up, or down. Okay, next we're going to go to our player machine, and we're going to add a new event. Now this is only for the alive state because the player won't be able to move when they're dead. So on, and the event type will be arrow button clicked. And for now, we're just going to use something called actions. Actions are like side effects. Actions don't change the state. They're just things that occur. They're like fire and forget. And this action, what it's going to do is just log whatever called it. So import log from XState, and we'll just see something in the browser console whenever this event is fired, which will just confirm that the machine is receiving the event, which is all we want for now. So now we have to update the player machine types. We have to add that event type. So export type arrow button click type, and type will be arrow button clicked. And this will have another property on it, We can add anything else to this event that we want, as long as it has a type that's any mandatory property. So I'm going to add direction here, and it will just be the direction type. So we have one event that will cover whether the player clicked up, down, left, or right. Okay. Now this is the first event we've had for our player machine. So I need to export type player event type. And for now, it's just this one event. Let's put that here. And we have to add this to our machine. Cool. So now we're going to go to our player component and wire up something that can listen to the keyboard events. So components, player. Okay, what I'm going to do here is create a custom hook. So let's make a new folder called hooks. And we'll call this use player controls.ts. Okay, so export const use player controls. And this function will take the props interface props type, and we're going to write for props handle arrow up, which will be a function that returns nothing. Handle arrow down. Let's copy that. Handle arrow left. And handle arrow right. Okay. So in our custom hook, we'll use the use effect hook. And it will listen for any of these 4 callbacks to change. Now we're going to put an event listener on any keyboard event. So document dot add event listener, key down, handle key down. And we'll define this function const handle d down. It'll take an event which will be keyboard event. And now we're listening to all key down events, but the only ones we're interested in are the arrow ones. So we'll make a switch statement, and we'll take the event.code, and if we have an arrow down event, we'll fire the handle arrow down function break. Similar thing for the arrow up, key press, handle arrow up. Great. Case for the arrow left, handle arrow left, break. Case arrow right, handle arrow right, and then break. So whenever the user hits any of the arrow keys, one of these 4 functions will be called. Now we just have to do some cleanup of our hook. So return function which will remove our event listener. Document.remove event listener, key down, and handle key down. Okay, so now we're going to use this hook, in our player component. So, because it's a hook, we'll add it up here. We're going to use player controls, which will take 4 arguments, handle arrow up, and what we want to do is use the send function to send an event to our machine, which will be arrow button clicked, and we also need to pass in the direction, and if it's the up arrow, we want direction type dot up, and we're going to do a similar thing for all the others. So I'm just going to copy paste this. Handle arrow down, handle arrow left, handle arrow right. This will be down, left, and right. Am I still getting an error? Two. XState has changed its API referring to this, but I don't think I've got the absolute latest version, so okay, we just need to make this an object with type. Okay. So if you're a little confused there, sorry. What we're doing is we're calling the send function, which sends events to our machine, or our actor in this case. And this send function, we're passing in an object, which has the type, which is our event type, and also the direction. So the machine should receive both of these if everything is working correctly. So let's test it out. If you remember on our player machine, if we receive this event, we're just logging it, so we should see it in the console. So I'll open up the console. I'm going to hit the up, then down, then left, then right. So here is our logs. We have the event, and the first one is the up, the next one should be down, third one should be left, and the last one should be right. Perfect. In this lesson, we're going to add the functionality to allow the player to move around on our grid. To begin with, I'm going to make 2 functions to make sure that the player doesn't accidentally leave our grid. So our first function, we'll be making them in the utility folder. And this function will be called get target cohorts. And this function is going to take 2 arguments, cohorts, which will be the coordinates, the current coordinates of the player, and a direction, which will be the direction the player wishes to move into. Cohorts will be cohorts type, and the direction will be direction type. Just import these. Cool. And what we're going to return is the new coords based on the direction. So we're going to use a switch statement for the direction. Let's fix the spelling. So we're going to need a case for each direction. So direction type dot up. In that case, we'll return the x coordinate won't change, so we'll just go coord 0. But the y coordinate, coords 1, will be -1 for them moving up. Okay, similar, we need to do direction type dot down. Return, we're going to turn an array of new coords. Again, the x coordinate would not change. The y coordinate would be +1. Now for direction type dot left, turn, okay, in this case the x coordinate would change, so coord 0, and it would be -1 if they're going left, and the y coordinate would not change. And for the last one, direction type dot right, return, again, the x coordinate will change and will be +1, and the y coordinate will not change. And we'll add a default case. We should never get to this, but just in case, we'll just throw error. Unknown direction, and we'll log out the direction. Getting an error. There we go. Okay, so again, this function, we're importing some weird stuff there. So this function takes the current coordinates of the player and the direction they want to move into, and will return the new coordinates. The other function we need to write is to make sure that this new coordinate is available on our grid. Because we want to make sure that our player does not leave our grid. So this function is going to be called isCoords on grid. Coords on grid. And it's going to take this new coords that we got from our previous function, and it's just going to return a Boolean, yes, it is on the grid, or no, it isn't. So we can do this pretty simply with Lodash. So in a previous lesson, we made an array of all our grid coords. So all we have to do is import that list and see if our grid coord is equal to any coord in that list. So we use Lodash is equal, and grid coord, and the player coord, the coords the player wishes to go into. Okay. Normally you'd write tests for these functions, but that's out of the scope of this course. Next, we need to go to our player machine where we will be using these functions. So at the moment, when the arrow button clicked event comes through to our player machine, we're just logging out the action. What we're going to do now is change that. So When this event comes through, we're going to calculate what square the player wants to move into based on the current coordinates and which arrow button was clicked. Now, then we're going to check whether that square is on our grid or not. If it is, we're going to update the coords to the new square. If it's not available, we're just going to ignore the action. And the way we're going to do that is with XState's function called choose. And choose is like an if statement or a bunch of if statements. And it allows you to execute actions based on conditions. So the way we can write that is, I'll just remove this log and I'm going to create a new action, and it's going to be on arrow button clicked. And then we'll add our machine options object. And we'll add actions. And then we'll add on arrow button clicked. And we're going to use choose and import that from XState. And it's a function that takes an array, and each object in this array will have a condition and an action. So our condition will be, and this will be a guard that we set. So at the moment it's just going to be a string, and we're going to say is square available. And if that does return true, we're going to execute the actions of move, which will update the coords. Now, if this condition returns false, we would then move to a second object and check its condition. But we don't have that, because if this returns false, we just want to ignore the action. So we only need one object in this array for our requirements. So now we have to define both this is square available and move. So we add a guards property to our machine options object, and we can add is square available. And this is a function that will take the context and the event, and it's going to return a boolean. And this will be the player context type, and this event will be the player event type. Now we have to check that the event type coming through is what we expect. So if event.type equals arrow button clicked, we'll put our logic in here. If another event called this guard somehow, we're just going to return false, because that shouldn't happen. So what we need to do, we're going to get the current player coords from the context. We're going to get the direction the player wants to move into. And then we're going to calculate the target coords using our getTarCoords function and passing in our coords and direction. So now we know the square the player wants to move into. We can then return is coords on grid and pass in the target coords. Well, this should be an object, not an array. That's why we're getting that error. Okay. So that is our guard for this choose action right here. So if this guard returns true, we're going to execute this action move. So we have to define move now. So just add move. And it's going to be updating the machine's context. So we have to use XState's assign function. Make sure that imported correctly. We don't want assign from Lodash. We want assign from XState. There it is. Okay. And again, this will take context and event. and it's going to be the same types as our guard. And we're going to be doing a similar thing. So we need the coords from the context. We need the direction they want to move into. We also need the target coords, so we know the square they want to move into. And now we just return coords, and it'll be the target coords. Okay. I think that is it. We're still getting an error. I think we're missing a bracket somewhere. Yep. So let's do a bracket around that. And around here, and there we go. Okay. So when the arrow button clicked event comes through to our machine, we're calling this action on arrow button clicked, which is defined here, which is using the choose function, which is kind of like an if statement for actions. Our condition is square available, which will return true or false depending if the square the player wants to move into is on our grid or not. If it is available, we'll execute this move function, which will update the coordinates in the machine's context. If the condition returns false, we'll just do nothing. So if we go to Storybook, we should be able to move around. So right, left, up, down. Now, if I try and go up here, nothing happens because the square is not available. If I try to go left here, nothing happens. If I try to go down here, nothing happens. And if I try to go right here, nothing happens. So perfect. Our player can move all around our grid and is prevented from moving off it. In this lesson, we're going to get our game to change from level 1 to level 2 when the player walks through the door. We're going to make the assumption that when the player reaches this square here, that will represent them walking through the door. So the first thing I'm going to do is go to our constants file, and we're going to make a new constant. So we export const door coords, and it'll be of coords type. And if we just go back to Storybook, this square here is column 11, row 1. So that'll be our door coordinates. And that'll be the same for level 2 as well. So we only need to define one constant. Next, I'm going to go to our game machine, and I'm going to make a new event type. Now, the way this is going to work is our game machine is responsible for changing levels. So what we're going to do is whenever our player moves, we're going to get the player machine to send the game machine the player's coordinates. And when the game machine receives those coordinates, it's going to check whether the player is on the door coordinates or not. And if it is, the game machine is going to change level. So in our game machine, we'll make a new type, the export interface player moved type, so player moved, and it's also going to have the player coordinates on it, coords type. And we'll add that to the game machine event type. Now, the reason why we're not putting this event on the player machine is because the player machine doesn't actually use this event. It just sends it to the game machine through an action, which we'll see in a sec. So let's go to our player machine. And we should have on arrow button clicked. We have this action on arrow button click, and we have this choose, and we've got is square available, move. So whenever the player moves, we want to send the event to the parent machine. So I'm going to make this array so we can call multiple actions. And the second action we're going to trigger is broadcast player moved. And we'll just add that to our actions. And this is going to use XState's function send parent. And what this function is going to allow us to do is send an event from the player machine to the game machine, which is the player machine's parent. So this function has two arguments, context and event. We're only interested in context. And we're going to need the player's coords, so const coords from the context. And we're going to make an event. And this will be of type player moved type, the type we just created. Type will be player moved and coords. The last thing we need to do is just return event. So that will send the event to the game machine whenever the player moves. Okay, so let's confirm that that is working. So we'll go to our game machine, and we're only interested in the player moving while we're in the playing state. So here we'll add player moved and actions. I'm just going to use the log function for now. Import from XState. Okay, so if this is working correctly, whenever the player moves, we should be seeing an event in the console with the player coords. Our console. So there is an event, and yes, it has the correct coordinates on it. So we are successfully sending an event from the player machine to the game machine. So now we can remove this log function, and I'm going to add a new action called onPlayerMoved. We'll go down to our machines options object, and we'll add an actions property. Now action onPlayerMoved. And this, we want to conditionally check if the player is at the door coords, and if so, we want to perform an action to change the level. So we can use XState's choose function again. In our first object, we'll need a condition, and we'll call it is player at door. And the actions we'll set is player walked through door. So we'll write our condition first. So we'll add a guards property. He is player at door. And this will be a function that takes the context and event. And we have to check if the event that called this guard is correct. So if event.type equals player moved, we'll put our logic in there, and if a different event called this guard by mistake, we're just going to return false. Now what we need is the player coords, so we can get them from the event. And we need to return a boolean, so we'll use low dashes is equal, and we'll pass in the player coords and the door coords that we defined at the start of this lesson. So that's our condition written. Now we need to write our action player walk through door. So if we look at our machine, we can see that to change from level 1 to level 2, we need to call the player walk through door event. So we can do this in this action here. So player walk through door. And what we can do is use XState's send function. And I'm just going to send the player walk through door event. So this send function can also take a target if you want to target another machine or service. but we just need to send this event to the machine here, so we don't need to define any target. So that should be all we need to do. So if we go to Storybook, we should see that when our player reaches this square, we change from level 1 to level 2. And we'll know that happened because this door is only on level 2. It's not on level 1. So move across here. And yep, there's our transition. So now we're on level 2. We've got a problem, however. So when the player moves to level 2, their coordinates are at the end of the level. What we want to do is move the player back to the start of the level whenever a level changes. So the way we can do that is, if I go to the player machine, we're going to make a new event type. This is going to be export interface reset player coords type reset player coords. We don't need that equals. Okay. So if we go to our game machine, and if I go to level 2, I'm going to use a property entry. And what this entry does is it will call whatever actions you define when we enter this level 2 state. So the action I'm going to call will be reset player coords. And we'll go to our actions and add reset player coords. And we're going to use XState send function again. It'll be reset player coords. And this time, I don't want this event to be going to the game machine. I want it to be going to the player machine. So we're going to add a target. So in this second argument, we add an object with a property 2. And we have to use the ID of the player machine that we invoked. So here's the invoke for the player machine, and the ID is player actor. So we'll add that there. So when we enter the level 2 state, this entry, we'll call this reset player coords, which is this action here, which should send this reset player coords event to the player machine. So let's go to our player machine. And we're only interested in the events when the player is alive. So I'm going to add it to the alive state. It'll be reset. Oh, if we go to, I think I've messed up the type. Yeah. So here's our reset player coords type, but I haven't added it to the player event type. So that's why the autocomplete didn't work. So let's go to our player machine, and it should be, we'll type reset player coords. And this will just call an action called reset coords. And we'll go down to our machine options, and we'll add a new action, reset player coords. And we're going to update the coords in the context of this machine, just to these coords, actually, the player starting coords. So if we're updating context, we have to use the assign function from XState. And all we need to do is return an object with the same property coords, and it will be the same constant player starting coords. Okay, so whenever the game machine enters playing.level2 state, the action reset player coords will be called, which sends a reset player coords event to the player machine. When that event is received while the player is alive, we'll call this action reset coords, which then updates the machine's context, the coords property, to the player's starting coords. So if we go to Storybook, we're on level 1. We move to level 2, and what should happen is we change level and this player should move back to these starting coords. Perfect. In the previous lesson, we made it so when the player reaches the door coords, the game changes from level 1 to level 2, and the player's coordinates are reset back to the starting position. In this lesson, we're going to do a very similar thing, just for level 2. So when the player reaches these door coords on level 2, the game will change from level 2 to level 3. Now, if we look at our game machine, the logic is already written for changing from level 2 to level 3. We've put this on player moved action in the playing state, not in the level state. So irrelevant of what level the player is in, whenever the player is moved, we're going to be checking if they're on the door coords. And if they are, this event's going to fire. Now, if this event fires while we're in the level 1 state, we change to level 2. If this event fires when we're in the level 2 state, we change to level 3. Now, if this event fires in level 3, nothing will happen because we haven't defined anything in that state. This is quite a powerful concept. It means that events are scoped to state. Now, you might be more comfortable with moving this into the level states. I'm just going to leave it here for now, but I think that's a matter of preference. So the only thing we need to do is add this entry reset coords to level 3. And that should be it. So we should be able to move all the way from level 1 to level 3. So we go to Storybook. We're on level 1 and now we're on level 2. We can see because we've got this door here. Now we'll know if we change to level 3 because there will be no doorway on the right. So move here and yep, level 3, and my player coordinates are reset. In this lesson, we're going to add this treasure chest to level 3, and when the player moves onto it, we'll change from level 3 to this game complete screen. So the first thing I'm going to do is go to our constants file and make a new constant. Let's call it const treasure coords, which will be of coords type. And if we look at our mockup, we can see that this is column 9 and row 2. So 9, 2. Okay, now let's make the treasure component. So if we go to our components directory, make a new folder, call it treasure. We'll have an index file. So the export const treasure. And we'll say const position, and we'll call our coords to position function. And we're going to pass in the treasure coords. And return. I need to make a layout component because this is going to be in our grid. Start grid, and it's just position absolute. So we are layout, and we're going to use our image component for the icon. It's not auto importing for some reason, so import image from image. And we're going to need to import our treasure chest PNG. So import treasure PNG from images / treasure.png. Source is that, and the alt will be treasure chest. The size of it will be the default, which is medium, which is our grid square size. And the only thing we need to do is style. And for left will be position 0 and top will be position 1. I think we just need to import React to get rid of the errors. Cool. So that's our component. So let's confirm that this is working. So we'll go to our game component. And the treasure chest is on level 3 and it needs to be in the grid. So our component is called treasure. Import that. So if we go to storybook on level 3, we should see our treasure chest. Perfect. Now we want to change our game so when the player reaches the treasure chest coordinates, the game changes from level 3 to the game complete screen. Our game machine is responsible for determining what screen the player sees. So we'll go to our game machine and we can see we've got the playing state and it's got 3 substates, level 1, level 2, level 3. And we're already receiving this player moved event from the player machine, which contains the player coordinates, what we're interested in. Now, irrelevant of what substate we're in, level 1, level 2, or level 3, this player moved logic will be executed because it is not defined in the substates, it's defined in the parent state. Which is good for level 1 and level 2. They've both got door coordinates that we want to check to change levels. But for level 3, it's irrelevant because there is no door on level 3. We want to check if the player is on the treasure coordinates or not. So what I can do is in the level 3 substate, define the event again. So the way this works is if we're in playing.level3 and the player moved event occurs, we'll execute whatever logic here and ignore the logic on the parent node. However, if we're in level 1 or level 2 substates and the player moved event occurs, the event isn't defined in the substate. So the machine will then go to the parent state node and see if it's defined there, which it is. So in our level 3 substate, when the player moved event occurs, what we want to do is check if the player is on the treasure coords or not. And if they are, we want to change to the game complete state. Now, how we change from the playing state to the game complete state is through this player got treasure event type. So we can do a very similar thing as we've done before. We'll add an actions to the player moved, and we're going to say on player moved final level. Go to our actions, add that, and we want to conditionally call an action, so we can use choose again. It's an array of objects, and our condition will be is player at treasure. And our actions will be, we'll say player got treasure. So let's write our condition in the guards property. Is player at treasure, takes context and event. Now we need to check if it's the right event type. So if event.type equals player moved. If it's not that event, we'll just return false. So const will get the player coords from the event. And again, we can use is equal, and we're going to pass in the player coords and the treasure coords. So that's our condition. Now for the player got treasure action. Now what we want to do is send an event to the game machine, and that event will be the player got treasure event. So we can use the send function again. It'll be the player got treasure. And I think that's all we need to do. So if we go to Storybook, we're on level 3, there's the treasure. So if the player moves onto the treasure chest, we should see the game complete screen. Perfect. In this lesson, we're going to add the player's health to the screen, which you can see up here represented by the 3 hearts. So the way we do that, first we go to our constants file, and I'm going to make a new constant, export const player starting health. And I set that to 3. And I'm making this a constant because in the future, maybe we want to make our game a bit harder or a bit easier. And one way we can do that is by changing what health the player starts with. And it'll be a lot easier if it's just in this constants file. So we'll save that. And now we'll go to our player machine. And I'm going to add a new value to the player's context. And we're just going to call it health. And its starting value will be player starting health. And we're getting an error because we need to update our player machine type. So in the context type, we just add health, and this is a number. And that should get rid of that error. Okay, so now we are storing the player's health in the player machine. The last job we have to do is render those hearts on the screen. So if we go to our components and our player component, we can access the player's health just like we're accessing the coordinates through the state.context property. So it'll be health. And I'm going to make a new component called health layer style.div. And this is just going to position our hearts in the top left of the screen. So position absolute. And for the top value, I've worked this out previously, so we don't have to go through trial and error during this lesson. So it's just space 30, and the left value is just space 2. And that moves it out of the way of our playing area. And we want to use display flex for the children. And so down here, we have to add a fragment because we are returning 2 components. So health layer, and we'll use our health component that we made in a previous lesson. Health, import that, which takes a property of health, and that will be equal to our health from our player machine. I think that's it. So if we go to our storybook, we can see we are rendering the player's health. Perfect. In this lesson, we're going to add the monster to our game. The monster appears on level 2, and it's represented by this green icon here. So the first thing we're going to do is make the monster machine. So in our machines directory, make a new folder, call it monster machine. And now we'll have two files, an index file and a types file. Okay, so export const monster machine, and we use XState's create machine function that takes three types. We'll just set those to any for now, and takes the first argument, which is an object, which is our machine config, and it'll have an ID, which we'll set to monster. It'll have a states property, and our monster will only have one state, and we'll just call it active. And it'll have to have an initial state, which is also active. And the monster will also have a context, which will contain its coordinates. Chords will be array, and if we look at our mockup, the monster is on column 8, row 1. So 8, 1. Okay, so now we just need to make the types for this. So let's go export interface monster context type coords, which is of coords type. We don't have any events at the moment, so we don't need to write anything for that. We just need to do the state type. So export type monster state type takes context, which is monster context type, and the value, we only have one state, which is active. Like the player machine, the monster machine will be a machine that is spawned from the game machine as an actor. So let's make the actor type. So export type monster actor type equals actor. Actor. Import and takes a context type, monster context type, and also takes an event type, but we don't have any events at the moment. Okay, so all we need to do is import these types into here. So the first one is the context type, so monster context type. The second one is the events, which we'll leave for now. And the last one is the state type. Okay, so now I'm going to get our game machine to invoke the monster machine. So let's go do the game machine. And now our monster is only available on level 2. So because we only want the monster machine to be in this state, we can use an invoke. So invoke, and we need an ID, and we'll call it monster actor, and it'll be a source, and it'll be monster machine. And we need to map this string down in our machine options. So in services, monster machine, and it'll be monster machine, and we can get rid of that. So now when the game machine enters the playing.level2 state, the monster machine will become available, and when we exit the level 2 state, that will clean itself up and go away. The last thing we need to do is render our monster. So if we go to our components and make a new folder, we'll call it monster. And in that folder, we'll make an index file. And this will be export const monster. And it'll accept an actor type, so interface props type actor, and it'll be monster actor type that we defined earlier, and add that to the component props type. And then the way we access our actor is through the use actor hook. Use actor from XState React, sorry. Let's pass in our actor. And then we want to access our monster's coordinates, so we can do that through state.context. This will be coords. And then we need to convert our coordinates to position values. So const position equals coords to position, and pass in our coords. And return, we'll be returning an image component with the monster GIF. So we need to import monster GIF from images monster GIF. Pass that in as the source, and the alt can be green slime monster. Now we also need a layout component. Const layout for style.div and position absolute. Import style components, and then we'll wrap our image with the layout component and add the position values to it. So left will be the first position because that'll be our X coordinate, and top will be the second one, which is our Y coordinate. We also need to import React. Oh, we need to import our image. It's not importing for some reason. Import image from image. That should be it. So we'll go to our game component, and we need to access our monster actor, which is available on this state.children property. Let's be monster actor, and this name has to match the ID we gave it when we invoked it. So monster actor. So that's all good. And this only exists in level 2. So we'll come down here, it's in our grid. So like with all actors, we need to check they're available before we try and render anything. And this will just be monster. We'll pass in our actor, the monster actor. And that should be all we need to do. So if we go to our storybook, we can see on level 2 we have our monster, and that should not be on any other levels. Perfect. Now we're going to add movement to the monster. So at the moment our monster is just sitting in one coordinate. What we're going to change is the monster will stay in this square for 2 seconds and then jump to the square below it and stay in that square for 2 seconds, then jump back to its original square, and it'll just cycle through those 2 squares. So the way we can do that is we go to our monster machine, and the first thing I'm going to do is change the state type. So at the moment we only have one state, which is active. I'm going to change that to 2 states. One will be up and the other one will be down. Let's go to our monster machine. So we no longer have this active state. This is changed to up, and we'll add this down state as well. And I'm going to make a new variable called coords list, which will be an array of coords type. And this array will contain the two coords the monster will have. So I'll have 8 and 1 as the top coordinate, and the bottom coordinate will be 8 and 2. And now we can change this to coords list 0. Okay. Now we're going to use something called a delayed transition. And what that does is when a machine enters a state, it can wait for a certain amount of time, then execute some functionality. So in our upstate, we're going to use the property after to define a delayed transition, and we're going to wait 2 seconds or 2000 milliseconds. And then when those 2 seconds are up, we're going to change to the down state. And similar in the down state, we're going to use another delayed transition, wait 2 seconds again, and then target the up state. So what this machine will do now is it will start in the up state, then after 2 seconds, it will change to the down state. Then after 2 seconds, it will go back to the up state. Then after 2 seconds, back down to the down state. And it will just keep oscillating between those two. So when we're in the up and the down state, we need to change these chords to the up chords or the down chords. So I'm just going to add an action here. So when we change to the down state, I also want to call this move down action. And similar here, when we change to the up state, I want to call a move up action. So we'll make our machine options object instead of actions. And let's do the move down one first. Move down. And because we're going to be changing the machine's context, we have to call XState's assign function. And we're just going to return an object with the chords property. And it's just going to be the second set of chords in our chords list. So chords list 1. Just add that. Okay. And the move up action will be very similar, except that it will be the first set of chords in the chords list. So when we change from the up state to the down state, these chords will change to the down chords. And when we move from the down state to the up state, we'll change to the up chords. And that should be it. So if we go to our storybook, we should see our monster moving. Yep, so it's every 2 seconds, we're changing from the down chords to the up chords and vice versa. In our game, we want to make it that if the monster and the player are on the same grid square, the monster attacks the player and the player loses 1 of their health. To do this, we first need to store the player coordinates in the monster machine. So if we go to our game machine and we look at level 2, where our monster is being invoked, we can see that this player moved event is coming through with this action on player moved. Now this player moved event has the player coordinates in it. So let's look at this on player moved action down here, and we can see it's a choose. And what's happening is it's checking the condition, is player at door? And if so, we send this player walk through door action. We can add a second option here. If you remember, a choose is kind of like a switch statement. So it checks the first condition, and if this returns false, we'll then fall through to the next one. And we're going to write a condition is monster. And this will check if the monster actor is available. And if so, actions, and we're going to say forward to monster. And we're going to write this action, and what this is going to do is it's going to forward this player moved event to the monster machine. Forwarding is just taking an event and not changing it at all, and just sending it to a different destination. So let's write this condition first. So is monster, and we'll go in our guards. Now a guard takes a context argument, takes an event argument, and there's also a third argument. It's condition meta. And this third argument allows us to access the machine state. So we condition meta.state, and then we want to access the state's children, which is where we can access our services. And the service we're interested in is the monster actor. and we're using the ID monster actor. So we can just add monster actor here, and we'll just make this a boolean. So this will return true if the monster actor is invoked, meaning we're on playing.level2 state, and it'll return false for every other state. So that's our condition taken care of. Now we need to write the action forward to monster. So the way we can forward an event is through XState's forward to function, and we just need to pass it our actor's ID. So if we go back to where the monster is invoked, we can see monster invoke, monster machine, and the ID is monster actor. So come down here and just pass it in that, like that. So what is happening if we're on level 2 or level 1 for that case, and the player moved event is sent to the game machine? This on player moved action will occur. And the first thing it's going to do is check the condition is player at door. Now, if they are at the door, we'll fire this player walk through door action and then we'll exit. However, if this condition returns false, we'll then move to the next one, which is checking the condition is monster. Now, if this condition is true, we're going to forward that player moved event to the monster machine. If it returns false, then nothing will happen. So now we just need to change our monster machine to react to the player moved event. So if we go to our monster machine, I'm going to create a monster event type. So export type monster event type. And this defines all the events the monster machine can receive. It'll just be one event, the player moved type. Import that. And because we now have an events type for our machine, our actor type has to be updated to include that. So this first argument is an events type. And we'll go to our machine. And we'll change this any to monster events type. And so we've got two states up and down. It doesn't matter which state. We're still going to be interested in the event whether the monster is in the up or the down state. So I'll put it above here, put on, whoops. And it'll be the player moved. And let's just do actions and let's just log this just to confirm it's working correctly. Import log, XState. So if we go to Storybook and we'll open up our console, we should be seeing an event every time the player moves. Cool. And this event should have the player coordinates on it. Perfect. Now that we've got the player moved event coming through to our monster machine, we need to store the player coords somewhere. So we're going to store them in the monster's context. So if we go to our monster machine types, and we go to its context type, we're going to add a new property and call it player coords. And that'll be of type coords type. And it's also going to be an optional type because we won't have these coords when we start. We'll only get them on the first player moved event. And then here we'll put player coords and we'll just put undefined. Okay, so now in our player moved event, we're going to remove this log and we're going to add an action, store player coords. So we go down to our machine options and we add a store player coords action, and we'll be updating the monster's context. So we have to use XState's assign function. And that takes two arguments, context and event. And we'll be returning, and what we'll be updating is the player coords, and these coords will be on the event dot coords. So whenever the player moved event is sent to the monster machine, we call this action store player coords, which updates the machine's context, the player coords property, with the coords on the event. And that's it. Whenever the player moves onto the same coordinates as our monster, or whenever the monster moves onto the same coordinates as our player, we want our monster to attack the player. The way we can do that is we can use this player moved event in our monster machine and add another action to it. We'll call this action attempt attack. And what this action will do is we will send an attack event if the player coords and the monster coords are the same. Now this scenario is when the player moves onto the monster's grid square. We also have another scenario where the monster moves onto the player's grid square. And we want this attempt attack action to happen when that occurs as well. So I'm going to add this action as to fire when we enter the up state and when we enter the down state as well. So these two will take care of when the monster moves onto the player, and this one will take care of the scenario when the player moves onto the monster. So now we need to define this attempt attack action. So in our machine's options object, in the actions property, we can add attempt attack. And because we are going to be calling a new action based on a condition, we will use the choose function, pass an array, and our condition will be is monster player coords equal. And if they are, we're going to make an actions and we're going to call it attack. So let's write our condition. So we'll add a guards property to options and then add is monster player coords equal, and that will take the context and event as arguments, and we need to return a boolean. So again, we're going to use low dashes is equal function, and we're going to pass in the monster coords and the player coords, and they're both on the context. So context.coords for the monster coords and context.player coords for the player coords. So if this returns true, we're going to trigger this attack action. And at the moment, we will just log this out to confirm it is working. So we'll use XState's log function. Yep. And I'm just going to write attack. Okay, so if we go to our storybook, and I'll open the R console. So we need to test two conditions. One, when the player moves onto the monster, and the second one, when the monster moves onto the player. So let's do the first one. So player moves onto the monster, and we got that attack. And so the next one, when the monster moves onto the player, and yep, we got that attack again. In this lesson, we're going to send an attack event from the monster machine to the player machine. So the first thing I'm going to do is go to our game machine types, and I'm going to add a new event type. It'll be export interface attack player type attack player. And we'll add that to the game machine event types. And I'm also gonna add it to the player machine event types. Just import that. So the monster machine, if we go here, it has this attack action. And so this is going to send that event to the game machine, and then the game machine is going to forward that event to the player machine. So let's get rid of this log, and we're going to use XState's send parent function, and it's going to send the event attack player. Okay, so now we can go to our game machine, and we're only interested in this event in level 2, where our monster is. So we can add it in here. So attack player, and we're going to make an action for this, actions, and it's just going to be forward to player. Go down to our actions and add forward to player, and very similar to the forward to monster, use the forward to function, and we have to pass in the ID of our player machine. So if we go back to where it's invoked, we can see the ID is player actor. So we'll add it there. So now when we're in the playing.level2 state and we receive the attack player event, we'll call this action forward to player, which will then forward the event to the player machine. So let's go to our player machine. Now we're only interested in the event when the player is alive, so we'll add this to the alive state. It'll be attack player actions, and we'll just log it for now, just to make sure it's working as expected. So go here. So remember, we have two scenarios: when the player moves onto the monster and when the monster moves onto the player. So if we open up our console, testing the first scenario, there's an event and it is attack player, perfect. Now the second scenario, when the monster moves onto the player, got another event, and again it's attack player, perfect. Now we have the attack player event successfully coming through to the player machine. So what we want to happen now is whenever we see this event, we want to reduce our player's health by 1. If that health ever reaches 0, we want to change the player's state from alive to dead, and then send an event to the game machine to make it change from the playing state to the game over state. So the first thing I'm going to do is remove this log, and I'm going to write a new function, and it's going to be called, a new action. It's going to be called reduce health. Come down to our machine's options in the actions property, add reduce health. And because we're going to be updating the machine's context, we have to use XState's assign function. And that will take the context and event, those, and we need to return an object with the property health, and it's just going to be the context.health value -1. So whenever we see the attack player event, we're going to reduce the health in the machine's context by 1. Now we need to check if this health value is 0, and if it is, we need to change to the dead state and let the game machine know so it can change to the game over state. So the way we can do that is by adding a new state called determining. And I'll just go to our types and update our state type. So now we have a third state called determining. Whoops. Cool. So whenever we reduce our health by 1, we're going to change to this determining state. And this state node is going to be a transitional state node. What that means is that whenever we enter it, we're immediately going to exit it based on a condition. So we add an always property to it to designate it as a transitional state node. And now we're going to be using something called a guard. A guarded transition. Now this is very similar to choose. Choose allowed us to trigger an action based on a condition. A guarded transition allows us to change state based on a condition. So it looks very similar. It's an array of objects, and we add a condition. We can add a condition to each object. And the condition I'm going to add here is health 0. And if that returns true, we're going to change to the dead state. Now, if that condition returns false, we will fall through to the next one. And this won't have a condition. We'll just add a target, which will be the alive state. So we need to write this condition. So we move down to our guards property. Is health 0. And again, this takes context and event. And we just need to check context.health equals 0. So what's happening is when the attack player event comes through to the machine, this action reduce health will be called. And that just reduces the health in the context by 1. We'll also transition to this determining state, which will immediately enter this guard. And this condition will be checked, is health 0. And if that returns true, we will change to the dead state. If it returns false, we will just change back to the alive state. So we also need to let the game machine know that the player has died. So in the dead state, we'll add an entry property which fires some actions when we enter the dead state. And the action we are going to fire is broadcast player died. We'll come down to our actions, add broadcast player died, and all we need to do is send parent, which is our game machine, and we already have an event for player died. So if we go to our types, there's the player died type. It's just player died. Okay. So send parent player died. So if we go to our game machine, and while we're in the playing state and the player died event comes through, we'll transition to the game over state. So that should already be set up. So when our player's health reduces to 0, we should see the game over screen. So get rid of this. 1, 2, and last one, and perfect. Okay, so all of our machines are completed, so we should be able to go through our whole game from start to finish. So we'll start on the home screen and we'll hit the start game button, and now we're in level 1. And when the player moves through the doorway, we get to level 2. Now, if the player is attacked by the monster 3 times, we'll see the game over screen and we'll hit the restart button and we're back to level 1. We'll move to the doorway again. Now we'll avoid the monster and get to the doorway, and now we're at level 3, and when the player moves onto the treasure, we get to the game complete screen and we can hit go home, and now we're back to the home screen. We're going to add some animation between each screen so it's not as jarring and has more of a game feel. So if we go to our code for these, I'm going to make a new component, and this is going to be called screen transition. Oops. Just an index file. And this is just going to be a style component. So export const screen transition equals style.div, and import style components. And this is going to be width 100% and flex grow 1 to make it 100% of the screen height. We're going to set display flex, and then we're going to add an animation, and it's going to be 2 seconds. And we're going to define this fade in for the keyframes, and we're going to use ease out. And so now let's define this fade in. So const fade in equals call keyframes from style components. Whoops, that didn't work. And at 0%, we're just going to set opacity to 0. And 100% it'll be opacity to 1. So we'll have this fade from black transition. So now we need to go to our game component. And at the moment, this game component is returning all these components based on what state we're in. So I'm going to wrap all these. Say const screen. And it's just going to wrap all of our components, and then we'll return screen. And so our game should still be working. Let's just confirm that. Yep. Okay, so now we can wrap this in our transition component. Screen transition. I'm getting an error. For some reason that's not. Whoops. There it is. Screen transition, and we need to add a key property, and just use JSON.stringify state.value. This will just make it so each time our state changes, a new version of this component will come out to re-trigger the keyframes animation. So if we go to our storybook, we get this nice transition whenever we are changing state. Okay, we've made it to the final lesson. We only have one small task left to complete our game. So throughout this course, we've been interacting with Storybook, and what we need to do now is connect our game to our app component. So we can now turn off Storybook and get rid of that. Now, if we go to our app file here, we can see this app placeholder component. We can just get rid of that and replace it with our game. So import that and go to our browser. We can see, and we refresh, we have our game. And that's it. So congratulations, you made it to the end of the course. Hopefully you're a lot more confident with XState and finite state machines. If you have any feedback about this course, don't hesitate to hit the feedback button below. If you would like a course certificate, a form should pop up at the end of this video. Just enter your name and it will be sent to your inbox.